Okay. Who can tell me the answers to this DOM? Austin.
The first one's -1, second one's -1,
Or what?
0.
Very good. -1, -1, 0, and 0. And why were those? Why did we have pairs? Why did we have things that were the same?
0.
What's the big key vocabulary word? Coterminal, yes. These two are coterminal. They are exactly 2 pi apart. And these two are coterminal. Today we're going to be graphing the sine and cosine functions. Now, here's the thing about graphing sine and cosine. It is because once you go around the unit circle one time, you're right back to where you started. So between 0 and 2 pi, we're going to be doing this in terms of radians. Between 0 and 2 pi, you have all these different values. Radical 3 over 2, radical 2 over 2, 1. You have all these values for sine and cosine. But then once you get back to the origin, it's just going to be the same thing over and over and over again. So these functions are called cyclical functions. They have cycles. Or they're also actually called, the more mathy term for it is periodic functions. They have periods. A period of a function is how long it takes for the function to repeat itself. So any function that's perfectly redundant with no added twists or differences in height, just perfectly the same thing again and again and again, it's said to be periodic. So here's how you're going to be graphing these today. Here's a raw cosine or sine function. Who has their unit circle in front of them? Josh. We'll start with sine. Sine of x. This is 4.5. Josh, what is sine of 0? I'm just going to punch in these values, and Josh is going to give me the y values. I'm going to punch in 0, pi over 2. Let's see. Actually, I could do even more than that. I will do more than that. I'll do 0, pi over 4, pi over 2, 3 pi over 2, etc. What is sine of 0, Josh? 0. What is sine of pi over 4? Which as a decimal is like 0.7 or something. So it's going to be right about here-ish. What is sine of pi over 2? 1. What is sine of 3 pi fourths? I didn't write that on here. Radical 2 over 2 again. Sine of pi? 0. Sine of 3 pi over 4? I'm sorry, 5 pi over 4. 5 pi over 4. Sine of 3 pi over 2 is -1, etc., etc. And then once we get to 2 pi, which we know to be coterminal with 0, we're right back to where we started. Now this isn't the best curve I've ever drawn, and there's one period of the cosine function. Now, because we're taking this straight from the unit circle, we know that the highest value that it could possibly be is 1, and the lowest value it could possibly be is -1. As are the values on your unit circle. So, all of these points came straight from your unit circle. And then after here, it's just going to start repeating itself. Because we've made one revolution around, and now it's just going to start doing the same exact thing every time you make a revolution around the unit circle. Similarly, it's going to do the same thing if I were to go in the negative direction. I'm not going to require you to do that right now, but if I asked you to find cosine of negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi, you would find those values. And you can see how, despite the fact that I'm not a very good artist, this function is just repeating itself. And those are 2 periods of this function. Raise your hand if you have a question about any of the terminology that I'm using, where I got those points. You could also use your calculator for this, yes. I'm getting these. You have your unit circle in front of you? All right. What is sine of 3 pi halves? Go to 3 pi over 2, and give me the sine value, the y value. It should be the bottom one. -1. These are the x values, hence sine of x. These are my inputs, and whatever the y value is, whatever you tell me, that's what it equals. That's my y value. So all of these are coming from the unit circle, or you have the option of using your graphing calculator to put it in. Now, notice, we're using radians, so make sure you're in radian mode. If you could punch in if you wanted to, sine, -3 pi over 2, etc. And you can even graph these things on your calculator today to get a visualization of them, but I still want you to draw them yourselves as well. Alright, let's look at cosine. We'll just switch colors and do it on the same exact graph. Shelby, what is cosine of 0? Circle, unit circle. 0. 0 is the straight to the right. What's the x value? 1. What is cosine pi over 2? The one at the top. 0. Cosine of pi. -1. 3 pi over 2. 0. 2 pi. It's back to 0. Yeah. 1. Very good. And I could ask you for these as well. I won't. And if you connected your dots, there's cosine. You might notice it's the same exact function, just shifted over. Oh, dang it. Same exact function, just shifted over. And that's not a fluke. All of these, again, are coming straight from the unit circle, or you can punch them into your calculator. And that is the cosine and sine function. Yeah. Yeah. Oh, think about it. All of their y values came from those two triangles, right? So they're all, I think the only values that are even on unit circle are like radical 3 over 2, radical 2 over 2, 1/2, and 1, positive and negative, and 0, positive and negative. So, yeah, they're just redundant. All right. Now, just like the other functions that we put on the board, or excuse me, on the wall, just like those, these have shifts and things. Now, you'll be surprised at how similar these things go. They're going to have amplitude, just like these did. Remember how the amplitude was the number being multiplied by the beginning that was going to stretch it? They're going to have periods, which we're going to talk about. They're going to have vertical and horizontal shifts, just like these. So today we're going to do, and which SPI is it? It is, one of those up there talks about trig functions and graphing them. Which one is it? Who can find it? 3.3. What does that say? Yeah, well, I may have paraphrased it. That's right. Graph and solve Ciliate trig equations and inequalities. Well, today we're just doing equations. So the first thing you need to write down. Now, even though this says sine, you need to write down somewhere in your notes. I'm not going to give you two of the same formula all day. This could also be interchangeable with cosine. It's not just for sine. A, sine, or cosine, B of x, has these properties that you need to write down. Amplitude is the absolute value of A, and the period is 2 pi over B. Amplitude is the absolute value of A, and the period is 2 pi over B. Especially, you can probably remember amplitude. The period is important to remember. It's a simple thing to find on a quiz or test if you have that little formula. While we're writing this down, who remembers? No, never mind. Not a good question to ask. Not a good question to ask. The amplitude. Here's how that's going to affect our function. Normally, our function only goes between 1 and -1, sine or cosine, both of them. The amplitude is something that we're multiplying by the entire function. So it'll be like 3 sine of x, or -2/3 cosine of x. Some number in the front we're multiplying by. that number is going to change your maximum and minimum values. So normally you would go between 1 and -1. If your amplitude was 7, then that kind of stretches it. And now your maximum is 7 and your minimum is -7. That's what an amplitude is going to do to a trig function. It takes your maxes and mins and stretches them or condenses them to whatever that number is, max and min. So let's look at those first. Determine the amplitude. Then graph the function. I'm going to be giving you specific ones to graph today, so you don't have to graph every single problem. What is the amplitude of number 1? 4. It's just the number being multiplied by the beginning. Positive or negative, you tell me the positive. What's the amplitude to number 3? 1/3. What's the amplitude for number 5? 3. Yeah, that's all it is. That's the only way you have to find those.
So I got 10 negative.
No, amplitude, you always give me the positive number. And I'll tell you right now, you're going to have a test question that's going to be like, what's the amplitude? And it'll look like this, and they're going to give you -3 as an option. So you need to make a mental note. Amplitude is always positive, just like it was for these. All right. Now, again, I'm going to quick sketch what these would do to our function. Let's say this is a normal sine function. Okay? Ish. A 4 amplitude is going to stretch my maxes and my mins and multiply them by 4. That would be approximately, granted if it was more symmetrical, what a 4 amplitude would look like compared to the original. How do you think a 1/3 amplitude is going to affect our function? It's going to make it smaller, yeah. A 1/3 amplitude would look like this. It would be really shallow compared to the original. It wouldn't be stretched like that, but I'm just not a good artist. What about -3? What do you think that's going to do? It's going to stretch it. What do you think the negative is going to do? Same thing it did on these. What was that? Yeah, it's just going to flip it. If you have a negative amplitude, it's still going to stretch it, but instead of starting out going upward, you're going to start out going downward. Like that. It's stretched, and it just flipped. Now, here's the beauty of these. For all of these, you can make an XY chart, or even plug them into your calculator to give you an XY chart, and you can see these. But if you actually plugged in 0, pi over 4, pi over 2, blah, 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 etc., into here, they would give you, and then multiplied by -3, this value, this value, this value. So when graphing today, if you remember these tips, they're quick problems. But if you don't, you can still make an XY chart and get accurate coordinates. All right. Determine the amplitude and then graph the... We've already done the amplitude. Oh, and period. Determine the amplitude and period. We're going to sprint through the amplitudes real quick. 1, 3, 4, 3, 1. Just the numbers in the front. The periods. Now, who can define for me what a period is again? Turn it off. What was the period of a function? Yes, but what's the definition of a period? Who can tell me? You ever going to get that thing turned off? Okay. Who can tell me what a period? Yes, sir. Heath. That's right. How long it takes to go through one cycle. Now, you may remember from lines and from these that any number being multiplied by your x, it's just like a speed, a slope, right? It's going to cause it to speed up or slow down. And that's what these are going to do. This is going to make you go through each period twice as fast. This one's going to make it go half as fast, so twice as long. So the periods of these functions are in this, and you just divide by whatever number is being multiplied by x. So in this case, 2. So what's the period of number 7? Pi. Number 9, 2 pi divided by 1/2. You can flip and multiply. And what is that period? 4 pi. Let's look at number 13. 2 pi divided by 2 pi. What's my period? 1. 15. 2 pi divided by 2/3, which is the same as 2 pi. Dang it. Times 3 over 2, so 6 pi over 2, 3 pi. it, 3 pi. And there's your periods. Here's how they're going to affect it. If this is our original, this means instead of taking 2 pi to make 1 full revolution, it's only going to take 1 pi. So this would look like it's going to go quicker. It's going to make 1 whole revolution in half the time. This one is going to take twice as long. So it would be like, it's going to stretch it. And similar, all the way across. That is how they are going to affect our function. Now let's look at one of these. Let's look at this one. I'm going to punch these into the calculator for us to see, and while I'm doing that, somebody raise your hand and tell me, oops, a little hobby of mine. That was just Star Wars. I don't know what you thought it was. It was just Star Wars, and there's nothing wrong with Star Wars. Alright, I need to make sure I'm in radian mode, because I'm putting in pi values. Y equals. First of all, I'm going to do regular sine of x. And then I'm going to do -3 sine of 2 pi x. I'm going to go to my window. -10 to 10 is fine. Actually, I don't need to go that far. We'll just go -5 to 5. That way it'll be bigger. And what's the highest and lowest point that this one's going to be going? Very good. -3 and +3. Just the amplitude. -3, +3. Now, before I hit graph, who can tell me how this one in all ways is going to compare to our original? Seamus. It'll be steeper because of the 3. And the period, what do you mean larger? That's right, so it's going to be just jagged back and forth, right? And what's the negative going to do? It's going to flip it. All right, let's look at it. Graph. There's the original, there's the second one. You see how much faster it's going? Because instead of taking 2 pi for a period, or 6.28, it's making a period in every 1 unit. So that's going 6.28 times faster. So let's just, wow, that's really condensed. Let me zoom out, and we're going to look at just one spot for a second. And you're more than welcome to do this today while you're working. There's the original. There's our new one. Now the original, from the one we first graphed for sine, starts at 0 and starts going up, right? This one starts at 0 and goes down, hence the negative. This one's going up very slowly because that's the normal pace. This one is going much steeper, much farther down because of the 3, and it's going much quicker because of the period. That's how all of these are affecting. Any questions about why any of this stuff is happening on the graph or where we are coming up with any of these numbers? Okay. Calculators? Yes. That's why I broke it down in you guys' quiz last Friday, which I should have finished and started grading by tomorrow, hopefully. Okay. Now, we've done amplitudes, we've done periods. What are the only 2 things left? Think about all the ways these graphs can move. We've done how high and low they go, we've done flips, and we've done how fast they go. What are 2 other things that can happen to any graph? Shifts. They can shift left and they can shift right, and they can shift up and they can shift down. If I remember, when we were doing these functions, Rachel, how did we know the difference between a vertical and a horizontal shift? Yes, but I mean, if you were looking at a function like x squared plus 2, how do you know if that's going to be a vertical or horizontal shift with that 2? Do you remember? Who does remember? That's right. If it was separate all the way to the side, it was a vertical shift. And if it was in the parentheses, it was a horizontal shift. Perfect. Now, for whatever reason, they don't want to call them horizontal shifts when it's trig functions. They call them phase shifts, but it's the same exact thing. So, you're going to need to know this. The phase shift of any sine or cosine function is given by that formula, C over B. C over B, where C is the number being added or subtracted to our x. Basically, that just means any sine or cosine function. Yeah. So if you have like, and it doesn't have to be x, it could be theta. You'll often see theta in there instead of x. So let's say it was 3 theta minus 6. Okay? This would be 6 over 3. Or if it was 1/2 theta plus 7, that would be negative 7 over 1/2. Remember, remember how in the past if it was like x minus 3, it actually went right, and if it was x plus 2, it actually went left? Same thing. That's why, even though this says minus, this is positive. You'll always take the opposite of this. So if this was plus 6, this would be negative 6 here. You're always going to take the opposite of that C value. Let's look at one. All right, find the amplitude, period, and phase shift. All right, let's just do all three. Let's look at 25. 25. Eeny, meeny, miny, Kaylee. What is my amplitude on 25? Positive 2. That's right, positive 2. What is my period on number 25? Eeny, meeny, miny, Kayla. Yep. Or you could even tell me the formula to find period. That's 2 pi over b. So 2 pi divided by 2 is what? There you go, pi. Now for my phase shift. I'll show the work over here. What is the number being added or subtracted to my x? Pi over 2. Now remember, you take the opposite of that. So it'll be negative pi over 2. That's my c value, divided by my b value, which is the same as negative pi over 2 times 1/2. If you flip and multiply, because this is the same as 2 over 1, which is, what is this when you multiply it out? Negative pi over 4. Well, it kind of was, because the negative c was up here in the equation. Now, if you wanted to change it, if you want to do this and just say plus and then make that a negative c, you're more than welcome to do that. But yeah, it essentially was just not actually in the c over b portion. Okay, now what on earth is that going to do? Well, that's the exact same thing as a horizontal shift. If that had just been minus 2, you take your thing and you scoot it left 2. That's it. Now, I know you're thinking, wait. It's horizontal. Doesn't that mean if it's negative, it goes right? We've already taken that into account by making this negative. So this is exactly what it looks like. We're going to take our function and shift it left pi over 4. Now, these phase shifts are hard to see, because since they're periodic functions anyway, a lot of times you're going to move the function like right where it would have been anyway. Not necessarily all the time. So phase shifts are really hard to see on trig functions. They're very subtle. Let me show you an example of what that would look like. Let's say this function started here. Now, I'm not going to take the amplitude or anything into account right now. That means every single point is literally going to be shifted left pi over 4 units. So this function would look like this. The same exact thing, shifted left ever so slightly, pi over 4 units. Sorry, I think it's wrong. And that's what that would be. If this was positive pi over 4, it'd be shifted right of the original pi over 4 units. When you're asked to graph these, if you're wondering, well, why the heck can't we just punch it in the calculator? Technically, you can. But if you remember these things, graphing these things can actually be pretty quick. So, if I was asked to graph 29, let me take 29 elsewhere, and I will graph him. Or her. Okay. So, here I go. I'm going to go ahead and make my axes down here for my graphing. We haven't done vertical shifts yet. We will in just a moment. They're the easiest part. Okay. First off, what is my amplitude? 2. Very good. What is my period? Very good. 2 pi divided by 2 pi is 1. And what is my phase shift? Negative c over b. Negative 2. Very good. Negative c over b. Negative 4 pi over 2 pi is negative 2. Now, here's a quick way to graph this if you remember this stuff. Where does sine start at 0? What was sine of 0? Not everybody all at once now. Unit circle. Sine of 0. I think you're thinking cosine. Sine of 0 is 0. So here's where I would normally start. Shabam. Now, first off, phase shift. Left 2 units. Boom, boom. Negative 2. Now I'm going to start here instead of at 0. My amplitude is going to, instead of going up to just 1, I'm going to go up and down to negative 2 and positive 2. Now, instead of taking 2 pi to make one whole amplitude, I'm going to be making a period, an entire period in how many units? How much? 1. And just 1 unit, I'm going to make an entire revolution. So, here's how you do that. You know that because you're making a period in one fell swoop, you're going to end up right where you started. In 1 unit. Okay? Now, from here, you know the general shape is, however, it's negative. So, you know you're going to come back to the middle. You're going to go down first because of the negative, and then up. And then you just keep drawing it. It can be that quick if you embrace these subtle tricks. The negative made me go down instead of up. I go to 2 and negative 2 because of my amplitude. I shifted left 2 because of my phase shift. In my period, I knew I was making one whole revolution in 1 unit. Let's say that had been a 2 pi. So I would come out 2 pi, or, well, this would be in pi if it was a period pi, but I would go up that far and make my dot. Then you put one right in the middle because that's what sign and trig functions do. If you go right back to our original drawing, just knowing what these original functions look like can make things a lot easier for you. In one period of sine, notice, every single time it's going to cross the axis right in the middle of these 2 points. So you just come to the end of your period, right in the middle will be another one, and then right in the middle of those 2 will be a max and a min. Max, min. Whichever one comes first depends on the sign of your amplitude. Let's look at maybe one more. And then we'll look at vertical shifts and be done. Look on the screen. Pick one out that you think looks froggy. We just did 21. And that's why we did it. That's not on. Is it 24?
Whatever the one before, I think it's
27. Actually, yes. Let's actually look at 23. I shouldn't, just because we just divided by a pi and we did it by number units. So let's look at one where we won't divide by pi, so we'll have to look at radial units. 23. That was my mistake. I should have just picked that in the first place. Thank you. Is he offended? All right. Here we go. Sabrina, what's my amplitude? Very good. Jordan, what's my period? Or how do I find my period even? Stop it. 2 pi over b. What's being multiplied by x? Yeah, nothing. So just 1. So what's 2 pi over 1? 2 pi. Very good. The period's not going to be changed because we have no b value. And my phase shift is negative c over b. So anything divided by 1 is itself. So this whole thing is going to shift left, pi over 2 units. Now, I would take the time to strongly encourage all of you to try to sketch this on your paper, but I have a feeling a lot of you would just kind of stare at a blank piece of paper without writing anything. So we're just going to jump straight into doing this ourselves. Now, first off, normally, I don't know why all these are sine. I wish they had some cosine ones too. Oh, I know why it doesn't. Okay. Normally, this would go as high as 1 and negative 1. But because of our amplitude, what's the max and min going to be now? That's right. Negative 1/2 and positive 1/2. That's as high and low as I'm going to go. Phase shift. Instead of starting at 0, 0 for sine, I'm going to shift left how much? Negative pi over 2. Now my period is 2 pi. So what is 2 pi units after negative pi over 2? And you can find this just by adding. What is 2 pi? I don't know why I put that over 2. 2 pi plus negative pi over 2. And that'll tell me where my period is going to end. 3 pi over 2. So pi over 2, pi, 3 pi over 2. Now, your calculator, one of the beautiful things about doing this by hand, your calculator is going to convert all that to decimals. So it'll be like negative 1.57, 1.57, 3.14. That's hard to find. So if you draw them yourself, you can actually just put pi over 2, pi, and it's easier to graph. So I'm going to start here. I'm going to end here. What's going to happen right in the middle of these two things? Every time on a sine function, what happens right in the middle? It's going to cross again. Now, am I going to go up or down first? Up. So I go up to my maximum, right in the middle of these 2 points. Bam. Then I go down to my minimum, right in the middle of these 2 points, and I'm ready to draw. And there is one period of this function, and you are more than welcome to draw as much or little of it as you. I guess I should do at least 2 revolutions. I'm not even going to label them because it's going to look the same. And there you go. Now let's graph on the calculator and see how accurate we are. That would be the best use of a calculator in this section. Use it to check how accurate you are. Now let's put in our exact window. I went from negative pi over 2, which it'll convert to a decimal, to 3 pi over 2. If you put in your exact window, it should look the exact same as what you did. That's why I'm doing this. Because if you put in a standard window, it's going to look like a little squiggle, and you're going to think you did it wrong. So we went as, well, I went as high as 1 to negative 1, even though we didn't need to. And here we go. Oh, dang it. I still have 3. I forgot to actually graph the function. So that was 1/2 sine of x, or theta. I guess I needed this. Plus pi over 2. Bam, and there we were. We started here, up to 1/2, cross, down, bang. And you can verify your answer. Why do you say that? Here's why it wouldn't be. If it had been, you're exactly right. If that phase shift had been negative 2 pi, then you're right. It would just perfectly overlap with itself. But it was negative 2. So you have to think in terms of the pi. So it would actually look a little different. But I get what you're saying. A phase shift by a multiple of 2 pi, negative 2 pi, 2 pi, 4 pi, negative 4 pi, you're not even going to be able to see a difference because you're just going to be overlapping the same exact function. So was that what you were implying? Yeah. So that's a good thing to know. Yeah, very good. You're not even going to be able to tell those. All right. Last thing was they just did the exact same thing with cosine. I don't know why they started. They did. So we're just going to jump straight into one. All right. Now, what are my vertical shifts? What's my vertical shift here? Up 2, down 3, up 1, up 2. Now, the thing to remember about vertical shifts on trig functions, unlike these, you can't just take some point and scoot it upwards. That's going to scoot up and down your max and min values. So like for this one, Without this, what would my minimum and maximum be? 3 and negative 3. But now I have to take both of those and scoot them up 2 units. Or, yeah, up. So it's going to be 5 and negative 1. It's going to kind of shift up your max and min values by that amount. So let's graph it. Last one, and then I'll cut you loose. Zach. What? Well, nothing's... Yeah. Zach, what's my amplitude? We're on 59. 3. Very good. What is my period? Shelby Emmons? 2 pi over 2 pi. Anything divided by itself? It will be. Phase shift. Who can tell me how to find my phase shift? Warning. Warning. Remember what Shelby said earlier. If they're in parentheses, it's going to affect your phase shift. If they're not in parentheses, it's going to affect your vertical shift. Is there parentheses here? So there's no C value. Therefore, there's no phase shift. Yay. So, none. And what is our vertical shift? Up 2 units. Up 2. Here we go. All right. Make your axes. I know I'm shifting up, so I'm going to make my axis way down here. Now, like you said earlier, instead of being negative 3 to positive 3, we're shifting up 2 units. So our minimum is going to be negative 1, and our max is going to be positive 5. Now, cosine at 0 normally starts at what x value? 1. Very good. But we're shifting up 2, so now it's going to start at 3. Very good. How long is it going to take me to make one period? 1. I'm going to make this nice and big so we can see it. Now, before I go any further, cosine, in my opinion, are actually even easier to graph. Let's go all the way back and look how cosine starts. Even though it's the same function, if you look at how it starts at 0, one cosine function really just makes a u. Believe it or not, that's the same exact thing. It's just shifted a little bit. So, I know that right in between these 2 points, I'm going to have my minimum. I'm going to go all the way down to my opposite minimum, because cosine functions start at their maximum, as you can see right here from our original. So, fast forward, fast forward, fast forward, fast forward, fast forward. No, I really went a long way. Okay. What was my minimum value for this function? Oh, sure poopy. I should have started at 5. Bam. Bam. Because I forgot to take into point my amplitude. I would have started at 3, but I had to shoot that up to 5. So these points are a little off. Right, negative 1. So right in between here, I'm going to have my minimum. And then from there, beauty of cosine, that's really all you need, is connect the dots. And it's going to keep doing the same thing and same thing and same thing. Let's see if we're right. Alrighty. I used a window from 0 to 1. The only thing I looked at. I went from negative 1 to 5. Oops, darn it. Forgot to do my scale. Negative 1 to 5. And my actual graph was negative 3 cosine 2 pi x plus 2 graph. Did I punch that in? Oh, dang, you're right. It naturally does parentheses. Thank you for catching that. Oh, it's negative. I forgot to take the negative into account. Dang it. Well, you can see how the negative affects it. It's just going to take the exact same thing and flip it over. So instead of starting at our maximum value, it's going to be our minimum, and this just flips. Dang, forgot to do the negative. That's... I'm sorry?
Where do sine functions?
Sine functions start at the origin. Cosine functions start at your maximum, which is normally 1. However, on this one it was 3, then shifted up 2, made it 5. But I forgot to take into account that the negative flipped it, so I actually should have started at my minimum instead of my maximum. That's the only thing. Notice this is just a perfect flip of this because I forgot to take into account the negative. I wish there was somewhere to note that in the stuff you draw out, but whatever. Questions? If you're excited and you know it, lay your head down. Okay, it won't have to be. Okay. Let's do it. Now I'm also going to write up here the only ones that you have to graph. The only ones that you have to graph are these. I'm going to write them up here. I want you to graph numbers 22. There'll be about 4 of them. 30. 50. And 58. Just those 4. Graph those 4. Everything else you can just give me all the data. Period, amplitude, phase shift, blah, blah, blah.